In this lesson, we will learn two techniques for solving two equations with two unknowns. These are often referred to as systems of linear equations. Now, a linear equation is an equation that can be written in the following form, and a system of linear equations is a pair of two linear equations. So, for example, this is a system of linear equations. Notice that we have two equations here with two variables, x and y. To solve this system, we must find a value of x and a value of y such that both equations hold true. Now, on their own, linear equations have an infinite number of solutions. For example, here are just a few solutions to the top equation, and here are just a few solutions to the bottom equation. We are looking for the one solution that both equations share. In this example, they share this one solution. So the solution to this system of equations is x equals 5 and y equals 2. Okay, now let's learn two methods for finding solutions. The first method uses substitution. So to solve this system, we must first take one of the equations and solve it for one of the variables. Now, it doesn't matter which equation we choose, and it doesn't matter which variable we solve for. However, it is a good idea to choose an equation that is relatively simple to solve for one of its variables. In this example, it is easiest to take the top equation and solve for y. When we do this, we get y equals 17 minus 3x. Now that we know that y equals 17 minus 3x, we can take the y in the second equation and replace it with 17 minus 3x. When we do this, we see that we now have an equation with just one variable, which we can solve for x. To do this, we'll first expand the left-hand side, and then we'll simplify the left-hand side. From here, we'll add 34 to both sides, and then we'll divide both sides by 8 to get x equals 5. Now that we know that x equals 5, we need to find the corresponding value of y. To do this, we can take any of the above equations and plug in 5 for x. So let's take this equation here and replace x with 5. When we evaluate this, we see that y is equal to 2. So the solution to this system is x equals 5 and y equals 2. Okay, let's summarize the steps involved in the substitution method. First, choose an equation and solve it for one variable. Then take the other equation and replace the chosen variable with its equivalent expression from the first equation. Then solve for the variable, and plug the solution into the equation to solve for the other variable. Okay, now let's examine another technique called the elimination method. This technique relies on the following properties. First, if A equals B and C equals D, then if we add the left-hand side and add the right-hand side, the results will be equal. Similarly, if A equals B and C equals D, then the difference on the left-hand side will equal the difference on the right-hand side. Okay, let's see how these two properties can help us solve systems of equations like this one here. Notice that in the top equation here we have positive 3y, and in the bottom equation we have negative 3y. Given this, notice what happens when we add the left-hand side and add the right-hand side. First, 2x plus 4x equals 6x, and next we have positive 3y plus negative 3y. When we add these, the y's cancel out. They have been eliminated. Finally, we have 10 plus negative 16, which equals negative 6. At this point, we are left with one equation with only one variable, which we can solve for x. When we divide both sides by 6, we see that x equals negative 1, so we already have half of our solution. Now that we know the value of x, we can plug this value into either equation to find the value of y. Let's use this equation, since its numbers look a little more manageable. So when we replace x with negative 1, we get an equation we can solve for y. First, we'll simplify the left-hand side, then we'll add 2 to both sides, and finally we'll divide both sides by 3 to get y equals 4. So the solution here is x equals -1 and y equals 4. Let's try another question. In this example, the coefficients in the two equations will not allow us to eliminate a variable by simply adding or subtracting the two equations. However, if we take the top equation here and multiply both sides by 2, we get the equivalent equation 6x plus 4y equals 18. Now if we take the bottom equation and leave it as it is, we now have 6x in the top equation and 6x in the bottom equation. So if we subtract the two equations, something nice happens. First, when we take 6x and subtract 6x, the x's cancel out. Next, when we take positive 4y and subtract positive 5y, we get -1y. And finally, when we take 18 and subtract 15, we get 3. At this point, we can solve this equation by dividing both sides by -1 to get y equals -3. Now that we know the value of y, we can plug this value into any of the above equations to find the corresponding value of x. Let's use this equation. So when we replace y with -3, we get an equation that we can solve for x. First, we'll simplify the left-hand side, then we'll add 6 to both sides, and finally we'll divide both sides by 3 to get x equals 5. So the solution here is x equals 5 and y equals -3. Okay, let's try one more. To solve this one, let's first take the top equation and multiply both sides by 3 to get the equivalent equation 6x minus 9y equals 3. Next, we'll take the bottom equation and multiply both sides by 2 to get 6x plus 14y equals 26. Since we now have 6x in the top equation and 6x in the bottom equation, we can subtract the two equations in order to eliminate the x's. So when we subtract 6x minus 6x, the x's cancel out. Next we have -9y minus positive 14y, which gives us -23y. Finally, when we subtract 26 from 3, we get -23. At this point, we can solve this equation by dividing both sides by -23 to get y equals 1. Now that we know the value of y, we can plug this value into any of the above equations in order to find the value of x. Let's use this equation. When we replace y with 1, we get an equation we can solve for x. First, we'll simplify the left-hand side, then we'll add 3 to both sides, and finally we'll divide both sides by 2 to get x equals 2. So the solution here is x equals 2 and y equals 1. Okay, let's summarize the steps involved in the elimination method. First, manipulate the equations until you have matching coefficients that will allow you to eliminate one variable. Then add or subtract the two equations to eliminate that variable. From here, solve for the remaining variable, and then plug the solution into any equation to solve for the other variable. Okay, now that we have two techniques for solving systems of equations, which method should we use when presented with a system? For example, which method should we use here? Well, in this example, adding or subtracting the equations will not eliminate a variable. However, notice that the top equation here can be easily solved for y. At this point, we can take the y in the bottom equation and replace it with 4x minus 1. Okay, how about this example? In this example, we have -3y in the top equation and positive 3y in the bottom equation. So if we add these two equations, the y's are eliminated, leaving us with an equation we can solve for x. Okay, let's summarize. In this lesson, we learned two techniques for solving systems of equations.